All right, so let's talk about RSA. Now that we can do modular arithmetic and modular inverses, we can do RSA. So if you start with P and Q, you always need these two prime numbers for RSA, P and Q. So if you use 7 and 23, then we can do key generation. Now you also have to choose a number E to be the part of the public key, and that you can just choose a small number like 3 or 5 and it's fine. So we're going to use 5. So here's key generation. Multiply the primes together to make n, then take p minus 1 times q minus 1, and that makes this number phi that you need. Now you select a public exponent e so that it is relatively prime with phi, and one simple way to do that is to always choose an e that is absolutely prime, like 3 or 5. Then this condition is always true. So now that I have p and q and e, I can calculate the private key d, and that is the multiplicative inverse, where d times e is 1 mod phi, because the people are going to encrypt data with e, and I'm going to decrypt it with d. And d is going to be my private key that nobody knows except me. So you can do the math involved here. Here's an RSA program to get you started where you've got, I used the WS before all my numbers here because I'd learned the proper best practice of COBOL to always do that. So I have P and Q and phi and N, and so you can enter P and Q and E, and then it will calculate some of these things for you, and it's going to call a modular inverse function. So you're going to have to create that modular inverse function, which is based on what you did before. It's going to just try a lot of numbers until it finds a number. You can multiply e by that turns it into 1 mod phi. So I'm able to give it a 7 and a 23 and e, and then it will give me the d is 53. So for these prime numbers and that public exponent, 53 is the private key. So there's some challenges here, and then you can perform encryption. The public key, to encrypt data, everyone can do that because your public key is E and N. N is the product of P and Q, and E is the public exponent. So anybody that wants to talk to you encrypts their data by raising it to the power E modulus N. And so that'll encrypt a single character. And so if I have 65 and 161 is N, I encrypt with E5. It calculates the encrypted value, which turns out to be 11 here. So that's encrypting. To decrypt, you take it to the D modulus N, because remember, you can't divide. All you can do is multiply further. So you encrypt by raising it to the E power, and you decrypt by raising it to the D power. And D is only available to the person who knows P and Q. And the person who only has access to N cannot typically find D, because that involves factoring a number into its prime factors, and that problem becomes very difficult for long numbers. These, of course, are not secure with these short numbers, but that's the logic of RSA. So you can make a decrypting program, and again, have the story here. And you notice, I think I found that the maximum size of any number in COBOL is 36 digits, and after a while I got fed up with it and just made everything 36 all the time, because we're eventually going to do some big numbers here. So now you can decrypt. Here's a public key that is 6 digits long. So first you're going to have to factor it, and you'll find you can try the thousands of guesses necessary very quickly. And then there's another one down here, and I think I got some where you actually have some serious big numbers. Yeah, here we go. X, Y, D, and N, we're getting up to maybe 10 or 12 digits here. And I thought I had an even bigger one. Yeah, decrypt without the key. Yep, anyway, so there's a variety of public key encryption there. And the point is, you can try really large amounts of guesses pretty fast. All right, so I'm going to stop this one.